Yeah, so let's start with the session today. So this is basically we will be solving EAC, previous EAC old papers, okay, based on module number 1. So problem solving lecture based on module number 1. All right, 26 1 24. Okay, so can you see this? This is 2014 paper, I think. Yeah, December 2014 paper, ESC paper, and we are going to solve the numericals which related to module number 1. So can you see the first question over here? Convert the given circuit into a single current source in parallel with a resistance between point A and B. So do you understand what it is asking? So in this numerical, it is asking us to find out to so is this a problem of source transformation? Yes, because we want at the end one current source, okay, either the direction will be up above or and with a series parallel resistance this way. So what is the problem for? It's a problem for source transformation, right? Like this. So we want to convert this circuit which is given over here into this circuit. So can we start? Anyone any ideas how to proceed forward? Any suggestions? This is the given circuit, so please draw it in your books. So if you are attending the lecture, it will be useful if you draw it along with me. So this is points A and B. This is 4 ohms, this is 8 volt, 10 volt and 5 ohms. We want this at the end. So tell me what we will do next. Yeah, everyone. Come on, you need to speak. So can we convert this 10 volt 5 ohms into a parallel resistance and a current source? Yes or no? And also we can convert this one also. So let's convert both of them together. So we can write by source transformation what do we get? Let me make it full screen if possible. Yeah, so by source transformation we can say this will get converted into a current source with a parallel resistance, and the other half also will be converted into a current source with a parallel resistance. Alright, now what will be the answer to the first one? Current will be voltage divided by resistance. So 10 volt divided by 5, 10 divided by 5, that will be 2 amperes, and this will be 5 ohm. And this 8 volt divided by 4, again it will be 2 amperes and it will be 4 ohms, and this is point A and B. Okay, so we want only a single current source and a single parallel resistance. So now how will you convert it next? What will you do next now? Yeah, students, come on, tell me. Y'all can hear me, right? So please let me know how to proceed ahead. So as you can see, this current source 2 ampere and this current source 2 ampere are in parallel. So we can add them together, and this resistance 5 ohm resistance and 4 ohm resistance are in parallel, as you can see. So next we can say, instead of two current sources we can combine them. So 2 ampere plus 2 ampere becomes 4 ampere, and this resistance will be 5 ohm parallel to 4 ohm. So please calculate this answer and let me know what is 5 ohm parallel to 4 ohm. You can hear me all right? Whatever I am doing over here in the white screen is visible, right? So let me know the answer of 5 ohm parallel to 4 ohm.
2.22.
Okay, so this is 4 ampere and the value is 2.22. Never ending 2, right?
Yes.
Yeah, this is what we wanted. So let's read the numerical again. Convert the given circuit into a single current source in parallel with a resistance between terminals points A and B. So this is the correct answer. That is correct. Yeah. So please complete it. Please complete this fast. Let me check if I have a solution to this numerical. Okay, anyways, old ESE papers. Okay, okay, I got it. Everyone got the answer. Can we move on to the next one now? Yes? Yeah, I got this. ESE, old ESE paper. Yeah, this one. Yeah, here is the paper, right? Let's check the answer. Yeah, 4 ampere in parallel to 2.22. So this is correct. Okay. So you should solve 5 minutes question in 5 marks question in 10 minutes time, mostly, maximum. So we started around at 12:07 and we have completed within 10 minutes. All right, within 10 minutes actually. So okay, so now let's go to, this was the problem of source transformation. Now let's solve another one now. So let's go to another numerical. Let's refer the paper. Okay, so find VAB using superposition theorem. Okay, so we have to find, let me write the question, you all can write the same. VAB using superposition theorem. Alright, let me draw the circuit again for your reference. Okay, let me just draw it properly. 10 volt, 5 ohm, 6 volt, 5 amperes, and this is point A and B. So yeah, that's the numerical. This is again for 5 marks. We have to complete it within 5 minutes. So how to proceed forward? Now you remember in superposition theorem, what is the procedure for superposition theorem? Anyone remembers? Yesterday only we have covered. You consider one source at a time, right? But we have solved using for finding the value of current, right? So here also the strategy is, first you consider 6 volts voltage source and find VAB dash. Then you consider 5 ampere current source, all the other sources will be deactive, find VAB double dash. And third case, consider 10 volt voltage source and find VAB triple dash. Alright, what is VAB? VAB is this voltage, plus minus. So can we start? Everyone ready? Okay, so let's consider the first case, 6 volt source active. So rest all the sources will be deactive. Let's draw the diagram. So this is 6 volt voltage source. What happens to the current source? Anyone remembers? When they are deactivated, they become open circuit and voltage source becomes short circuit. So this is point A and B. This is 5 volt, 5 ohm resistance. Now tell me what is the voltage between VAB. So what is VAB dash? How much it is? Yeah, tell me. So this circuit we can draw it like this, right? This is open circuit and this is actually VB only. So this is A, this is B, this is 5 ohm, this is 6 volt. Now can you tell me how much is the value of VAB dash? Hello? Yes, it's 6 only, na? It's parallel voltage directly. So directly the answer is VAB dash is 6 volt. Alright, it's correct. Have you noted down? Can I go to the next step? Yes. Okay. So next we consider 5 ampere current source active. Rest all the sources will be deactivated. So 6 volt voltage source will be short circuited. 5 ampere current source will be as it is. Then this is 5 ohms and this also will be short circuited. Now this is very challenging. I mean, I want to know how many can give me the correct answer. Now tell me what will be your answer. What is VAB double dash? So how this circuit gets converted? Can you tell me? Yesterday I have discussed about the important concept that anything parallel to a short is a short. So now can you tell me how much is the voltage VAB double dash? So this upper short makes this 5 ohm resistance redundant. Okay, so upper part is replaced with a short circuit, whereas lower one is also replaced with a short circuit, right? Okay, so this is your A and B. A and B. Now tell me how much is A and B? VAB dash. It's short circuit, na? A and B is short circuited. So how much is the value? Hello? 0, right? A and B is short circuited. So its value is 0. Do you agree, everyone? Come on, tell me yes or no so that I can go next. Hello? Do you agree to this or you have any questions?
Yes, sir.
Alright. Now let's consider 10 volt voltage source alone. So let me draw it here. 10 volt source active. Okay, so this 6 volt and 5 ampere will become deactivated. So this is 6 volt voltage source will get deactivated. Current source will become open circuit. Then we have a resistor of 5 ohm over here, and then we have a 10 volt voltage source over here. The direction is plus here, minus over here. Okay, and we have to find VAB triple dash. Let me write over here 10 volt. Now tell me how much is VAB triple dash?
Is it minus 10?
It is
Minus 10.
let's see. So let's try to understand. This is a short parallel to anything will be a short only, right? So it will be over here like this. So this is A, this is B, and it is 10. How it is minus 10?
VAB plus 10 is equal to...
Nahi, this is plus minus, na? This is in parallel with this plus minus. So it's 10 volt. How minus? Correct, na? V is always positive with respect to B, and this is also positive with respect to B. It would have been minus if the polarity of VA, this thing would have been negative. ऐसे होता तो then it would have been a minus. So if this is the case, if this was 10 volt, then VAB would have been minus 10. Understood?
Yes, sir.
Because here it is minus, this is plus, but this is plus, this is minus. So this is just for your information. Okay, so we have solved this numerical. No, not solved, but we will be writing one statement by superposition theorem. By superposition theorem, we can say VAB is equal to VAB dash plus VAB double dash plus VAB triple dash. Now what was VAB dash? 6 volt. 6 plus 0 plus 10. So VAB will be 6 plus 0 plus 10. How much is that? 16 volt. So that is the answer. Got it? So please complete it fast. You all are following, right? So right now the time is 12:25. We started at around 12:18. So we have completed it under 7 minutes. So that's okay. Anything under 10 minutes is fine. For 5 marks numerical or a question, you should not spend more than 10 minutes. Completed? Can we go to the next one? Everyone? Yeah, so this is your paper. So other questions are based on other modules. Our favorite, nodal analysis, have come. It will be a good practice, and it is asked for 6 marks over here. Find the current through 4 ohm resistance using nodal analysis. So let's attempt this. So let me draw the circuit over here for you all. So this is third question for today. Find the current through 4 ohm resistance using nodal analysis. So please draw the diagram, please. This is 3 ohm, 6 volt. Now let's note down the time. It's 12:27. So we need to complete it as early as possible and accurately. This is 5 ampere. This will be 6 ohm, 4 ohm, 2 ohm. Alright. So my 4 ohm resistance is here. So let me mark the current over here as this one. This is the value of current we want to find out. So please note down the diagrams quickly. And now we will start with the analysis. Okay? Shall we begin? So before going to the solution, we have to identify the nodes. So this is one node, this is another node, and this is my reference node. So I mark it as a ground. Let me call this node voltage as A, and this is B. So node voltage over here is VA, this is B. So we'll solve it by nodal analysis. So let's start. We have to define the current directions. So let's say this current direction is here, I1, this is I2, this is I3, and I4. Is there a super node over here? No, there isn't a voltage source directly connected between two nodes. So it's a normal nodal analysis. So let's start applying KCL at node A. What does it give you? Incoming currents. All are outgoing currents. So I1 plus I2 plus I3. All are outgoing, right? Is equal to 0. What is I1? VA minus 6 upon 3. So VA minus 6 upon 3 plus I2 is VA minus 0 upon 6. So VA upon 6. I3 is VA minus VB upon 4. So VA minus VB upon 4. That is equal to 0. Now we have to solve this. 1 by 3 will be, can you calculate and tell me? 0.3. 0.33, right? This will be 0.333 VA minus 2. What is 1 by 6? Can you tell me by calculator? How much it is?
0.16.
Okay, 0.1 never ending 6. 0.1667 VA. Then 1 by 4 will be 0.25, right? Is it correct? Yeah. So now we add them together. So please add 0.333 plus 1.666 plus 0.25, and this is VB. So let me know this answer of VA. What is the coefficient? VB is 0.25 and this is 2. Let me know this coefficient of VA. What is 0.333 plus 0.1667 plus 0.25? How much is the...
0.75.
Alright, so we got the first equation. Now we apply the KCL to node B. KCL, I mean nodal analysis is easy, provided you are very strong in your calculations. Okay. So here incoming current is 5 amperes. So phi equal to outgoing, one more incoming current is there, sorry. So there are two incoming currents, I3 and 5 amperes, and outgoing current is I4. So we can write I4 is equal to I3 plus 5. So how much is I4? VB upon 2. I3 is VA minus VB upon 4 plus 5. So let's solve this. This is 0.5 VB equal to 1 upon 4 is 0.25 VA minus 0.25 VB plus 5. So what do we get? 0.25 VA. This will become minus, so minus 0.75 VB equal to minus 5. This is equation number 2. Let me know if you get the same equation. And now let us write in a matrix form. So we have over here VA, VB, 0.75 minus 0.25 to 0.25 minus 0.75 minus 5. So you need to tell me the value of VA and VB. Come on, quickly tell me. VA is
5.5 volts.
and VB.
8.5.
Alright. So now what is I3 or what is current flowing through 4 ohm resistance now? I3 is VA minus VB upon 4. So let's find out that I of 4 ohm resistance is VA minus VB upon 4. So it will be 5.5 minus 8.5 upon 4. So actually minus 3 by 4, right? So current flowing through 4 ohm resistance is minus 0.75 amperes. Direction we have assumed was left to right. But if you want to write current positive, then assumed direction was wrong. We can write 0.75, but the direction will be this manner. Correct? So did you all get 0.75? Hello?
Yes, sir.
Let me cross check the value which we have earlier solved. Just a minute. ये देखो same. Earlier I have solved this, so the numerical value was around 0.75. It's correct. We are in the right direction. So we started this at around 12:27 and it's around 12:34. So we have again taken 7 minutes. So good time. Alright. So it's good going. We can solve more numericals. So this was asked for 6 marks. Now All of you ready? Can we go to the next one? Okay. Now these are all other numericals. Using source transformation, find the current through 10 ohm resistance. We want to do source transformation, or should we go to the new numericals? Can you tell me? Source transformation we have done one. So can I move on to the next one, or you want me to solve this? Quickly tell me. Hello? You want me to solve this, or we'll go to the next numerical? Yeah, tell me so that I can proceed as follows. Again, you want me to solve a problem on source transformation? Yes or no? So I think we have solved one. So this one you can manage on your own. I'll provide you this paper ka solution. You can check it out. We'll move on to this maximum power now. First of all, yeah, this one 8 marks. See, earlier they used to ask for 8 marks, 6 marks, 4 marks, but nowadays the norm is either 5 marks or 10 marks. So be prepared for 5 or 10. So let's refer this. For the given circuit, find the value of RL for maximum power transfer and calculate the maximum power absorbed by RL. Okay, so it's a maximum power transfer theorem statement. So let's find out. So let's draw the numerical. Everyone please draw it at your end. So we have to find RL and we have to calculate maximum power. So straightforward a maximum power transfer theorem. So let me draw the circuit again. You also please kindly draw it in your books. Okay, you have a resistor over here and 10-volt battery source over here. Alright, this is 1 ohm, this is RL, this is 5 ohm and 8 ohm. So I'll maximize this part now. Please note down the diagram. Completed? Yeah. So here what is the procedure to find out? It's very recently topic. So first we'll find RTH, then we'll say RL is equal to RTH as per maximum power transfer theorem, then we'll find VTH, and then we'll find Pmax, which is VTH square upon 4 RTH. Alright, so these are the 4 steps. So let's start with RTH. Tell me what we do in the RTH. So basically this is my point A and B. Okay, and this is my resistance RL. So we remove RL and deactivate all sources. Yes or no? So let's draw the circuit again. This is for point A and this is for point B, and we have this 2 ohm resistance. So what happens to this battery? It becomes a short circuit, right? Like this. Alright. Now tell me how we will solve it further. So instead of drawing this 2 ohm resistance above, I mean from outside, can I draw it from inside? What I mean to say this. Any problem with that? Yes or no? Can we do this way?
Yes, sir.
Now tell me how will you proceed further? Is 1 ohm and 8 ohm in series? Yes or no? 1 ohm and 8 ohm are in series?
Yes, sir.
They would have been in series if, let's say, let's imagine that this 2 ohm resistance was not present. Then how we would have drawn the diagram? Okay, 4 ohm, 5 ohm, and this was circuited. Yes or no? And this was A. But right now what is happening is they are not connected. There is a 2 ohm resistance, and then we have another 2 ohm like this, 1 ohm, 8 ohm, and then this is B. Now tell me whether they are in series or something. They are not in series, they are in series only with this and this. So between A and B, these are in series. So in that sense 4 ohm and 5 ohm is also in series. No, na? Are they in series? When are the two resistance in series? When the one terminal is tied together. Now over here one terminal is tied together like this at B, directly at B. So they are in series or no? Come on, tell me fast. Yes or no? Students, come on. We have to solve other numericals also. Yeah, let me know. Why I cannot say they are in series, they are not in series? Because we have to find this between point A and B, right? So there is a tapping over here, tapping over here. They cannot be in series. How could they be in series? If I have removed this, na, 2 ohm resistance, then what I can say, 4 ohm and 1 ohm would have been in series, 5 ohm and 8 ohm would have been in series, correct? But now since we have this 2 ohm resistance, it cannot be in series. So what technique do we apply over here? What is this looking like? A delta, right? So can we convert delta to star? You remember? Hello?
Yes, sir.
See, I'll again, I understand you have a doubt. So let me draw this. I'll tell you why this is not in series and what can be in series. So in this diagram, this was the 1 ohm and 8 ohm, right? If B would have been over here, if point B would have been over here, then 1 ohm plus 8 ohm we can write. But what is happening over here in our case? In our case, even if this is 2 ohm, still we could have written 1 ohm parallel to 8 ohm. Are you understanding? But in our case, what is happening is B is not over here, B is over here. So these two resistance 1 ohm and 8 ohm are not in series. So 1 ohm and 8 ohm are not in series. I hope it is being followed. I mean, you're following this. Okay. Even if the B is here, even if B is here, still they will be in series. Are you getting my point? What I'm saying? So now we will apply the what is this network's delta or star? You know delta and star, right? Hello? Long forgotten or what? Yeah. Now tell me, is this a delta network or a star network? Network formed by 1 ohm, 8 ohm and 2 ohm. Tell me. Yeah. So this is delta, convert into star. So for converting into star, draw that star network like this. Okay. Let me call this resistance R1, R2, R3. Now you refer the formula for delta to star and tell me what is R1. Come on. You can refer your formula for R1. So how do you write R1? 2 ohm into 1 ohm, right? How do we write it? Come on. To make you recollect. So, see, adjacent to R1, which are the two resistance? 2 ohm and 1 ohm. So, 2 ohm, let me write it properly. 2 into 1 divided by total, right? 2 plus 1 plus 8. How much is that? 11, right? So, it's 2 by 11. Agree or no? Similarly, R2 is 1 into 8 divided by 11. So, 8 by 11. And R3 is uh, 2 into 8 divided by 11. So, 16 by 11. Do you agree with these values? Yeah, students?
Yes, sir.
Now, please tell me, let me know the values also. What is 2 by 11? 2 by 11 is how much? 0 point.
0.181.
And 8 by 11?
0.727.
And 16 by 11? 1 point.
454.
Okay, it's a recurring series. Now, redraw the network only with this, this, and the red one. Do not touch the blue one at all. Okay, we replace this. So let's draw this again. It's a star delta one, right? Sorry. Yeah, let's draw it. For my reference, I am keeping it a little short. So I'm redrawing it over here. So this is 4 ohm, 5 ohm. Then we have now we can narrow it down. This is R1. How much is R1? 0.1818. This is R3. 1.4545. And this is R2. This is 0.7272. Yeah, we got this. And now we need to calculate. See, whenever there is a problem is tricky, it will take more time. So don't worry. This is A, this is B. Now tell me, any resistance are in series or parallel? I think these two are in series, right? And these two also are in series individually, correct? So let's quickly find out. So this is 4.1818 parallel to 5 plus 1 point is 6.4545, correct? And that is in series with 0.7272. So please let me know the answer of parallel combination of these two. What is 4.1818 parallel to 6.4545? Let me know. Hello? Yeah. Let me know this.
2.5376.
So this is point A, this is point B. Calculate RAB, please. RAB is 2.5376 plus 0.7272. That is how much?
3.2648.
3.2648. Yeah, that should be fine. Let me cross check with the old answers. If it is correct, then we are in the right track. Sorry for this. Yeah. We are getting 3.27. Earlier I have solved, I have approximated it, but 3.2648 is absolutely correct. Okay. So we have taken some time, actually lot of time, for star delta for RL equal to RTH. Sometimes it comes, sometimes it happens. Then what can we say for the second step? We can say that for maximum power transfer theorem, for MPT, maximum power is transferred from the source to the load when RL is equal to RTH. So this is RTH. So it's 3.2648. So this will fetch you some marks. Then what is the third step? To calculate VTH. Correct? So for VTH, what do? We draw the entire circuit without RL. So let's do that quickly. Please follow, increase your little bit speed. Alright, and then we have it over here. This is A, this is B, and the values over here, let me just cross check it. 4518. This is 4 ohm 518. And now instead of drawing this, we don't have RL, right? So instead of drawing 2 ohm and 10 volt outside, we'll draw it inside. Alright, we shouldn't have any problem. So what I'm saying is this: instead of drawing it outside, we'll draw it inside. Nothing is wrong, it's correct only. 2 ohm and 10 volt, right? Yeah. Now we have solved similar numerical. Do you remember? So how to solve this further? Tell me. What is VAB? So VAB will be start with B and then go above. Yes or no? We did this way only, na? So this point is A, this point is B, and this over here is VAB. Now you apply your KVL over here. So let's say current in this loop is I1 and current in this loop is I2. Yes or no? Now tell me, according to KVL, around this yellow part loop where we are going from which direction? This direction. So this is the direction which we are going. Now tell me, how will you start? Start from B. So tell me the value. Here this direction and current direction are same, so it's minus, right? Minus 8 I2. Then this direction and this direction opposite, so it will be plus 5 I1. Then you are going from plus to minus, so minus VAB equal to 0. So how much is VAB? Minus 8 I2 plus 5 I1. So basically we need to find I1 and I2, correct? So this is equation number 1. Now in loop number 1, can we apply a simple Ohm's law like thing or no? Can we apply the simple Ohm's law over here in loop 1? No. Why no? Hello? Earlier in the numerical we could have drawn it, but right now this 2 ohm resistance is set between these two loops, right? So the current will be different. That's why we have to apply mesh analysis. So apply KVL to mesh 1. What do we get? Hello? Tell me.
Minus 11 I1.
Minus 11. Acha, directly you are saying. So, okay, fine. Let me go by the traditional method. I1 minus or plus? Minus, no? Minus or plus?
Either minus 1 right? Minus 2 is I1.
Minus 2 I1, but plus I2 or minus I2? Because normally in a loop, what do is, let's say the current direction is this way, we keep the current direction almost opposite only, so it's correct. So how much it will be? See, normally in a mesh analysis, what do is, see, let's consider this example. Okay, where we apply mesh analysis like this. So these current and this current are not in the same direction. Yes or no? That's why we write it as minus. Yes? अभी यहाँ पे क्या हो रहा है वो बताओ.
यहाँ पे plus है. Same direction.
हाँ, तो same direction. That's what I said. Yeah, this is very tricky. Then minus 4I1 minus 5I1 minus 10 or plus 10? Plus 10 is equal to 0. So it will be minus 11 I1 minus 2 I2 is equal to minus 10. Correct it is now? Mesh 2 KVL. Tell me. Again, minus 8 I2 minus I2, then minus 2 I2 plus I1. Yes or no? So it will be minus minus 2 I1 then minus 11 I2 is equal to 0. So solve, is this correct?
So don't we consider the voltage source?
Yes, we do consider a voltage source. It again it is plus 10, no? Now it is correct? Is this correct now? Equations are correct. Can you find the current I1 and I2?
Zero point 769.
I1
Both. 769.
amperes. Now I'll tell you an important lesson. Listen here. Last time we have solved a similar numerical, but there was no resistance. Now, if I find the current by Ohm's law, simply by Ohm's law, I1 is 10 divided by how much is the total resistance? 11, right? Calculate this, how much it is by Ohm's law.
0.9090.
So it would have been different, right? Let me just we are still to find VAB, right? Let us find VAB first and then we can cross check. Okay, so by this technique it's different, answer is coming different. Now let's find VAB. What is VAB equation? Minus 8 I2 plus 5 I1. Please calculate this and let me know. How much it is? Both the currents are same, so
Minus 2.3076.
correct. Let me cross check with this. See, minus 2.30. Correct now? Yes or no? We getting it correct. Earlier I've solved this 1 year back. Now the answer is coming exactly the same. So this method is correct. The only trick over here is this. This is where student make mistake. You understood now why we put my plus over there? Yes or no? See, this numerical is very tricky. It has eaten up your 20 minutes up till now and still we have not solved it. Yes or no? We started at around 12:37 and it's now 12:58, 21 minutes gone. Okay, so these type of numericals also come in exam. It may look very simple. See, on face, if you look at it, it's a plain numerical. You will find it's very simple, but when you try to solve it, it becomes complex, right? So you need to concentrate. Don't let your guard down anywhere. This is VTH. Alright. Now similarly, now what is left out? Calculate Pmax. Pmax is VTH square upon 4 RTH. Please calculate this much. Minus 2.3076 square divided by 4 into RTH. RTH was how much? 3.2648. 3.2648. Only this much is left now. We have taken around 22 minutes to solve this.
Minus 0.001.
माइनस
0.407.
नहीं, माइनस कैसे आएगा? -2.3 का स्क्वायर विल बी प्लस ओनली ना?
कैलकुलेटर में डाला तो माइनस आ रहा है.
नहीं, अरे माइनस का स्क्वायर विल बी प्लस ओनली ना. सो -2.307 स्क्वायर डिवाइडेड बाय ये करो, माइनस, इट कैन नॉट बी माइनस. डू इट अगेन एंड चेक.
0.4077.
4077. Let's cross check this. See, 4 point. So it's correct, absolutely correct. And we have taken 22 minutes. So see, I was asking you all questions based on that before. So you, what is the trick is, just a simple register over here has complicated everything. Earlier you remember we solved a similar numerical on Thevenin's that where have no resistor, and we have easily solved it using Ohm's law. But here when a resistor is common between the loops, you have to apply mesh analysis. Got it? And here I1 plus I2, if you don't write this, then it will be wrong. You will get a wrong answer. So it's a very tricky numerical, and it's took our 22 minutes away. So you can get simple numericals, but you have to be careful. I'll tell you one thing, the trick is, if the numerical given numerical is very complex, the solution will be very simple. If the given numerical is very simple, the solution might be tricky, like this one. See, by looking at it, it looks like a simple problem, but when we solved it, it took away a lot of time and understanding. Got it? Yes, can we solve the next one? Okay, yeah, probably we have half an hour left, so we have to do it in a fast pace. So this covered Thevenin's and maximum power theorem. Agree? You have started applying Thevenin. Star delta also covered. So see, lot of numericals have concepts are covered over here. First we apply delta to star. Okay, I have to write over here. This was delta to star. This one. Okay. Then we have applied Thevenin's theorem and find out the value using maximum power theorem. Okay, fine. So next we'll solve another numerical on superposition theorem. Today we have solved the superposition. So you want me to solve it again, or can we move on to the next one?
Next question.
Okay. So I'll close this. And I'll open another one. Let me see if I have. So this is the question paper. This was the question paper, June 2023. Now, which type of, let me know what type I will ask, should I solve over here? Which technique you want to learn? Norton's, Thevenin's, mesh, nodal, superposition we have covered today. So see this, I'll show you numericals. Nodal we have solved already. This type we have solved already. This type also we have solved. This is super mesh analysis. You want to solve this? Hello? Yes or no? Tell me.
Sir, can you solve one Norton theorem?
Norton, if it is there or no, let me check. This is nodal analysis. Okay. Right now, in this paper, we don't have Norton's theorem. So first, let me complete this super mesh. Then I go to Norton's theorem last. Okay. So, because super mesh will be covered now by this then. So find out current through 5 ohm resistance using. Fortunately, they have given only in the numerical super mesh concept. So please draw the diagram. So let me draw it over here. It is 50. So for example, I'm giving you for super mesh or mesh analysis, draw the diagram bigger so that you can draw the, identify the currents carefully. Okay, so this is 5 ohm, 1 ohm, 2 ohm, 10 ohm, 2 ampere and 3 ohm. Please mark it. And we are going to solve this. This is I1, I2, I3. All are in same direction, opposite direction. Sorry. Can we identify why it is a super mesh? Can you tell me? Because a 2 ampere current source is set between loop 2 and 3. So you can write loop 2 and 3 form a super mesh. Does this resistance in series with the current source matter, or it does not matter? Yeah, it does not matter, because anything in parallel with a current source is redundant. Series with a current source is redundant. So same 2 ampere current source will flow over here. So 2 ampere, loop 3 and 2 form a super mesh. Yes or no? Now what is the equation of this current source relation? Is it I3 minus I2 or I2 minus I3?
I3 minus.
I3 minus I2 is 2 ampere. So this is equation number 1. Then KVL to super mesh. Tell me. So where will we apply KVL? Around the loop, here, the yellow portion. So let's start applying KVL. So what do we start over here? Not this branch, 3 ohm and 2 ampere, we leave it around the loop. So it will be minus I2 minus 5 I2 minus I1, right? Then come over here, minus 10 I3 minus I1, then minus 2 I3 is equal to 0, correct? So please sort this out. 6 then you have minus 12 I3 is equal to 0. Okay, then where do we apply KVL? We got 2 equations. Where do we get the third equation from? KVL to loop number 1 over here. So here this is minus, this is plus, so we are going, this is 50 minus 10 I1 minus I3 minus 5 I1 minus I2. I hope you are following what I am doing over here. Okay, so
Sir, ऊपर 15 I1 रहेगा ना?
15 I1, yeah, correct. So this will be also again 15 I1, right? 15 I1 plus 5 I2. Please cross check this. Equation number 2 and 3 cross check once more. Okay, are they fine? Oh yeah, I have to write over there equal to minus 50, right? On this side, so that I can easily put on calculator. Now it is correct. Yeah, so this will be 0 minus 1 1 2. This will be 15 minus 6 minus 12 0. This will be minus 15 5 10 minus 50. Is this proper now? So find out I1 I2 I3. I1 I2 I3, how much? Anyone with the answer?
Sir, I1 is 30.
30 amperes.
Yeah.
Okay, and
I2 is 25.333.
okay, I3
सर मुझे I1 20 आ रहा.
is the equation same?
हाँ मेरे में.
So what is correct? I1 is 20 or 30? Anyone also got the
Sir, 20.
I2?
17.33.
Never
Sir,
ending.
15, sorry 15. I3 17.
अच्छा I3 17. 17.33.
Yes.
अच्छा ठीक है. Okay, might be. So what is I of 5 ohm resistance now? I1 minus I2 we can consider, right? We consider this direction down, let's say. So what is I of 5 ohm? I1 minus I2. How much it is now? 4 point something. 20 minus 15.33. How much it is? 4.66, right? Correct,
Yes.
eh?
हाँ sir.
And the direction is down. Let's check this answer. ये देखो 4.67. So correct, absolutely correct. And we have solved it. We have solved it in 11 minutes. Okay, so good. We are strong in MS analysis, and it was asked for 10 marks. So 10 marks numerical in 11 minutes is commendable. Alright, everyone got the answer. So see, doing so much, I mean, you have learned the concept, right? So just you can see 3 equations and solving it correctly will fetch you 10 marks. So you can understand the importance of solving the numericals correctly and accurately. Alright, now let's go for Norton's as requested. So let me take a recent paper. I'll take ISC paper, is it fine? Last year's ISC exam paper, let me check. Re-ISC solution, I'll check. Norton's theorem was not there. Let me check in ISC paper solution. हाँ ठीक है, fine ना, no problem at all. We'll solve this. See, नहीं इसमें भी Norton's theorem नहीं है. We'll take a old paper. Practice test. I'm checking if I have a Norton's theorem of paper on. Oh, this is practice test number 2. Superposition, Nodal, Norton's theorem. I've given them assignment. Let me check. Assignment 1 and 2. Here it might be, huh? Okay. Maximum power, Norton's theorem. Can we solve this? Hello? Which do you want? We have this one and this one. 6 or 7, tell me.
कोई भी चलेगा.
Okay. So we solve this one. This was a assignment numerical which I've given to students last time. Not for marks, but for practice. So let's solve this for today. And that will be a last numerical for today. So find I of 1 ohm resistance using Norton's theorem. So please draw the diagram, please. Everyone, this is 1 ampere. There is a voltage source connected here. One ohm, 2 ohm, 2 ohm, 1 volt, 3 ohm, and 2. So where is RA, RL? This is RL, 1 ohm. So where is A and B? Point A is over here. Let me mark it with a different color. Okay. Please complete the diagram. So this is A, this is B. Alright? Understood everyone? How do we do Norton's theorem? First we find Thevenin's equivalent resistance or Norton's equivalent resistance. It is same as RTH. Then next we find IN, Norton's current or short circuit current. And then we find the value through the load using Norton's equivalent circuit. So can we start now, everyone? Yeah? Ready? First we'll find Rn, same as your Thevenin's equivalent resistance. So remove the load. So this is RL. Remove 1 ohm resistance and redraw the circuit. Redraw the circuit, deactivating all sources. So this 1 ampere will go. This 1 ampere will become open circuit. Then here we have 3 ohm resistance. Here we have 2 ohm. Here we have 2 ohm. And here we have 2 ohm. This is point B. This is A. And RL is open. And here there is a short circuit, right? Yeah. Now tell me, how will you solve this further? Yeah. Now this is, we have seen this earlier. Can I say 2 ohm and 2 this 3 ohm and 2 ohm are in parallel? Yes or no? Because they both the points are same, right? So let me redraw this in a way you will understand. This is 3 ohm, 2 ohm, and there is a short over there, right? And then there is again 2 ohm, 2 ohm, and again you have B. Can you now say these are in parallel, right? Yes or no? So what is 3 ohm parallel to 2? 2 ohm parallel to 2, I know the answer, 1 ohm. 3 ohm parallel to 2, how much? 1 point something, no?
1.2.
And these two are in series. 1.2 ohm, 1 ohm. So what is RAB? RAB is 1.2 plus 1, that is 2.2 ohm. Got it? Understood? Everyone? Yes or no? This is nothing but your RN or your RTH. Yeah. Everyone ready for the next part? So the next part, for finding the value of Norton's current, you need to draw the circuit again, remove RL, and connect A and B with a wire, short circuit A and B. Okay, so let us do that now. So I'll draw it over here. We are finding IN, Norton's current. This is 1 ampere. Okay, this is 3 ohm. That will be 1 volt voltage source. Okay, Oh, sorry. And we have to short circuit this, right? This is A and B. This is A, this is B, 2, 2, 1 volt, 2. Huh. So what we have to find? Current between this iron, Norton's current, this current from A to B. This current we have to find. Now tell me what theorem you will apply. What we will do next? How will you find this? Hello? Any ideas? So there are actually how many loops? 1, 2, 3. There is a fourth loop also. So can we convert this 1 ampere 3 ohm into by source transformation? Yes or no? This is a voltage source with a series resistance. Yes, can we do that?
Yes.
But it will be in series with what? Just wait. Don't transform it, just wait. But it will be, I mean, it's connected to a lot of things, so it cannot be directly. Yeah, why not? The question is, can we apply source transformation over here? Yeah, they are in parallel. Yes, definitely. So how will it look like? Correct? This is A. What will be here? Open, right? Will the diagram be like this? Yes or no? This is 3, this voltage source will be 3 volt. Do you think it will be like this? By source transformation it will become like this? Yes or no? What?
Can't we apply KVL to 4 loops?
We can, but how will you solve in calculator?
I1 will be 1, right?
Yeah, you can. You can it. You can solve it directly. That was I was asking you all continuously. Can we solve this using directly? So here we directly apply KVL to the other loops because one loop we know. Correct. So this is I1, this is I2, and this is IN. And this current over here, let's say this current over here, even if we consider I4, what is I4?
1 amp.
No, -1.
-1, -1.
That's it. Apply KVL to other loops. So this will be, sorry, let me write in black color. Okay. So mesh analysis to loop number 1. So KVL. Okay, I have to close this document and start again. It's giving me trouble. Just a second. Problem solving. Yeah, we got it back. KVL to loop 1. What do we get over here? -3 I1 minus I4, right? Yes or no? Then -2 I1 minus IN. Yes? Are you understanding? This is third current is this IN. Then +1 or -1?
+1.
Yeah. And I4 you substitute the value. So it will be -3 I1. No, -3 no. minus 5i1, right? Then it will be plus, this will be minus, and this will be minus this thing. So how much it will be? Minus 3 plus 2in plus 1 is equal to 0, right? Just cross check this. Equation number 1. Now we apply KVL to loop number 2. So we have minus 2, this is I2, minus 2 I2. Then this will be, we are going from plus to minus, so minus 1. Then here it will be minus 2 I2 minus IN is equal to 0. Correct? It will be minus 4 I2 plus 2 IN is equal to 1. This is second. And then KVL to loop number 3 will give you minus 2 IN minus I2 minus 2, here it will be IN minus I1 is equal to 0. So it will be plus 2 I2 plus 2 I1 minus 4 IN is equal to 0, right? So here are the three equations. Solve them together to get the answer. I1, I2, IN. Hopefully it should give you the correct answer. Minus 5, 0, 2, 2, then 2. Okay, equation number 2 is over here. So 0, minus 4, 2, 1, 2, 2, minus 4, 0. Yeah, solve this and let me know the answer of I1 and I2 and IN. Actually we are interested in IN current only, but tell me the answer.
Minus 0.6363.
What? I1, I2, I3?
I1.
Minus 0.63.
6363.
I2?
Minus 0.545.
Okay. And IN?
Minus 0.59090.
Anyone else getting the same answers? Just for confirmation. Yes or no? Alright. So Norton's current is minus 0.5909, right? You're getting this answer? So what will be the next step? Drawing the Norton's equivalent circuit. So Norton equivalent circuit is like this. A and B. What is the value of RL? 1 ohm. RN, IN. RN is how much? 2.2, right? RL. How will you find I of RL? Or this is 1 ohm resistance. I of 1 ohm resistance will be by CDR, current division rule. The other resistance, that is 2.2 divided by 2.2 plus 1 into minus of 0.5909. Tell me the current. How much is the value of the current?
0.406.
Minus, na?
Minus.
406 amperes, correct? And the direction we have assumed is down, right? Correct?
Yes.
So assumed direction is up. So that's the answer. Let's see if it is matching. Yeah, it's matching, 0.406. So it depends upon what direction of current we assumed. See, we assumed the direction of current to be down. Okay, here like this. But actually it came reverse. So it's absolutely correct. So yeah. So with this, we have completed this on time. And we have completed this numerical. We started around 15, right? So around 15 minutes. Norton's theorem for 10 marks. So that's fair enough. for 10 marks numerical, at least 20, maximum 20 minutes you can spend. Okay, so yeah, we have covered mesh, nodal, source transformation, star delta, Thevenins, Nortons, maximum power and superposition. So we have revised all the topics which were covered, or all the concepts which were covered in module number 1. Alright, so I hope this session was beneficial, and I've recorded this. I'll share the recording with all the students. Alright, so that's all from my side. If you have any questions, you can ask.